Hello everyone, this video is made for those who need to know how to create a voltage multiplier circuit. The team that made the project is composed of Jesús, Salvador, Aranda, Villagran, Álvaro Martínez, Daniel Hernandez Rodríguez, and me, Humberto Rodríguez Fraire, for the subject of Electromagnetism of the engineering career in telematics of the Polytechnic University of San Luis Potosi. As mentioned above, the circuit works in such a way that it enters an alternative RMS voltage that is multiplied by the square root of 2, and it will give us the peak voltage, which in turn will be multiplied by 4, thus having the quadruplicator of voltage. It is also worth mentioning that the professor gave us a margin of 5%. Finally, to say that the project was made in a printed circuit which required a separation of 5 mm between the tracks so as not to provoke an electric arc.
In the simulation of the multisim project, capacitors of 26.8 and 3.3 microfarads were used and resistances of 296 and 330 kiloohms were used in series to have a total of 626 kiloohms. The circuit that was carried out for this project was half-wave. In the first capacitor there is a peak voltage, while in the other three there are two peak voltage. The diodes are used to rectify the alternating voltage to direct. The resistors was connected from the positive side of the source to the node where capacitor 4 is connected, and the diode located to the right of the circuit. The nominal value of the input voltage was 119 volts, obtained from a battery of independent voltage, and the output of 654.8 volts. This voltage is in the resistance. The nominal value of the current in the circuit was 1.008 milliamps.
To make the circuit assembly in the PCB, it was necessary to buy 18 capacitors. All these at 215 volts. 6 of them needed to be of 4.7 microfarad and the rest of 3.3 microfarad. We need 4 diodes of the order of 4070 and 4 resistance. 2 resistance of 100 kilos and the other of 330 kilos. The first combination of capacitor was done with 6 capacitor of 4.7 microfarad. The other 2 combinations were made in such a way that they could withstand a voltage no higher than 500 volts. The combinations were made for 4 capacitors, 2 pairs in series and then this pair in parallel. The diodes were placed in such a way that the cathode and anode alternate, this in order to rectify the voltage. The combination of resistance was made with 4 resistors. The resistors were placed at the node of the first capacitor and the other combination, and the other part of the end of the last capacitor and the other. In this way, we were able to measure the voltage and current delivered.
The waveforms of current and voltage are very similar, although different in magnitude. For external issues and beyond our reach, the waveforms will be shown with the simulation. we can observe the waveforms behave in the same way, but the voltage range by division is different. In conclusion, the project was very simple, but requires precision since there are external problems such as tolerance of capacitors and resistance affected us when entering their minimum range. As we know, there is a big difference between simulation and the practice, because in the last one we can't control everything. In this way, we can say that the results are as expected, because the circuit entered 118 volts of RMS voltage, which by applying the corresponding mathematical operation, in addition to the 5% of margin that we have, had to give us a minimum of 634 volts measured with a multimeter in direct current. In the resistance of 330 kilo ohms give us a voltage of 337 volts, while in the resistance of almost 300 kilo ohms give us a value of 330 volts. So in total we have a voltage of 640 volts, thus exceeding the minimum range voltage. Finally, applying the Ohm's law with the values of voltage and resistance, we have a little more than 1 milliampere.